Good afternoon, sir.
Can you see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
No, sir.
Yes, sir.
Please don't forget to keep mic off. Right? So that your mic should not get disturbed. Okay, so yesterday we were talking about reflexive relation, and all of you understood. Right. So some relation defined on some set said to be reflexive if every element is related to itself with that relation, then the relation is reflexive. So we saw many examples, and from that clear that relation is reflexive. Right. Any doubt regarding reflexive relation?
No, sir.
No, sir. No, sir.
Now we'll try to see the next type of relation, which is symmetric relation. So let A be a non-empty set, right? Then a relation R on set A is said to be symmetric if the relation R is symmetric. So we are given a set and we are given a relation, and that relation is symmetric if whenever x y belongs to R. Okay, let me write down in different way so that whenever x is related to y, reflexive if whenever x is related to y imply y is okay, let me make more clear. If x is related to y with respect to relation R, you want to write down very precise. So x is related to y with respect to R imply y is also to x with respect to relation R. So whenever x is related to y, then y also related to x. Then relation is symmetric. That is. So what is another way to say same thing? Relation R is reflexive. See, when I say x is related to y, that means what how do we alternatively say this? Ki xy is in R, right? Where xy is in R means x is related to y. So relation R is reflexive if xy belongs to R implies yx is also in R. Right.
The relation R is symmetric, na?
Not symmetric. We'll see examples. Right. There are many examples. We'll see. Just first of all, try to understand definition and we'll see example. Ki whenever x is related to y, then y also must be related to x. But if x is not related to y, then don't worry about whether is y is related to x, right? So that is alternative way. R is reflexive. R is reflexive if x is related to y, implies y is also related to x. So these are the different ways to say saying same thing. So let us
Symmetric.
no, symmetric, not reflexive. I am talking about symmetric. Need to
Sir,
be
you have written reflexive.
oh, so let me correct it. Thank you. So I am talking about symmetric. So is symmetric. Okay, fine. Now definition is will be more clear if we see example, right? So let us suppose my set A is 3-element set A, B, C, and suppose I define a relation. Let us say relation R1 is A comma A, B comma B, A comma B. Right, so I will give another relation A comma B, B comma A. Right, I will define another relation on same set A comma A, B comma B, C comma C, A comma C, C comma A. Right, now compare these relations. So first relation R1, is it reflexive? First of all, reflexive, is it reflexive? First,
No, sir.
No, sir. No, sir.
because for reflexivity, we need to check is every element is related to itself. So A is related to A, B is related to B, but C is not related to C with respect to R1, so not reflexive. Right, so is it symmetric?
No, sir.
No,
It is
sir.
not
No,
No,
sir.
symmetric. Right, so it is not symmetric because A is related to B. Right, pair AB is there, that means A is related to B, but B is not related to A because pair BA is not there. Right, so pair BA is not there, not in relation R1, therefore B is not related to A. Right, so as soon as A is related to B, then we need to check whether B is related to A. So not symmetric. Right, so please keep your mic off. So A is related to B. What is the reason? So you should write down the reason why. I think you understood why it is reflexive and why not symmetric. So you should write down all the details later on. That will be helpful to understand the concept. Alright, so let me give you one more here. A comma A, B comma B, whatever is this. Okay. Now second R2. Is R2 reflexive?
Not
not
reflexive.
Not
reflexive.
reflexive.
No, not reflexive.
No, sir.
Not reflexive. Why not
But
reflexive? Because A related to A is not there. B related to B is also not there. So no, some elements are not related to themselves. That condition fails. So not reflexive. Is it symmetric?
Yes, sir.
yes, sir.
Yes, sir.
Yes, it is symmetric because whenever A is related to B, B is also related to. That's it. So symmetric. Right. So you write down all the reasons why. Fine. R3. Is R3 reflexive?
Yes, sir. Yes. Yes,
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 sir.
sir. Yes.
R3 is
Yes, sir.
reflexive. Is it symmetric?
Yes, sir.
Yes, sir.
Yes, yes. Yes,
Symmetric.
sir.
Yes, sir. Yes, sir. Symmetric.
Yes, sir.
Symmetric also because A is related to A, B is related to B, C is related to C. Now A is related to C, then C is related to S. That condition fails. Now A is related to B, and B related to A, we are not worried about this because A is not related to B with respect to this relation. So we do not bother about whether B is related to A, right? So we are not worried about A related to B and B related, because A is not related to B with respect to R3. So we should not bother about whether B is related to A, right? So you write down all the reasons why this relation is reflexive as well as symmetric. Now what about R4 next?
Not reflexive and symmetric.
Not
Not
reflexive and not symmetric.
not
Not.
not reflexive, but is it symmetric?
Symmetric. Yes, symmetric.
Yes, symmetric,
Yes,
Symmetric.
sir.
right?
Yes, sir.
So it is symmetric because there is no pair AB, so we should not bother about BA, right? There is no pair AC, so we should not bother about CA. There is no pair BC, so we should not bother about CA, right? Whenever AC is there, then we should bother about whether CA is there, right? Not then, don't worry. So therefore, this relation is not reflexive but symmetric. So why? Think over it. Fine. So this is a simple way example. Now, suppose x is equal to set of all lines in the plane. Suppose x is the same example which we had yesterday. So I will define relation. So define relation R1 on x by, so for L1, L2 in x, L1 is related with L2 with respect to this relation if and only if L1 is parallel to L2, right? So this is my first relation. Second relation I am going to define on the same set is define relation R2 on same set of lines. So what is set X? Now you can imagine what are the objects. Whenever I say the collection of set of all fruits, then each object is a fruit. Fruit is object. Whenever I say set of all lines, then the line is object, right? Suppose I want to choose one object from this set, I will choose a line, entire line. Remember this. So now the broad view of broad meaning of set, collection of lines. So line L1 is related to line L2 with respect to this relation if L1 is perpendicular to L2. Okay, now is first relation, so is R1 reflexive?
Yes, sir.
Yes, sir.
Is R1 symmetric?
Yes, sir. Yes, sir. Yes, sir.
Right. So it is reflexive
Yes.
because every line is parallel to itself. Every line is parallel to itself. So you just close your eyes and put your hand in the set X. You will find some line. No matter what line you select, it is parallel to itself, no doubt. Now, suppose some line, I have some line L and I have some another line. Suppose line L is related with line M. What does it mean? So if L
Is parallel.
is related to M, that means L is parallel to M. But if line L is parallel to M, this is line M and this is line N. If L is parallel to M, then M is also parallel to L. Then M is parallel to L. What does it mean? M is also related with L.
L.
Correct? Very good. So that means if you have line L parallel to M, then M must be parallel to L. But see, you may have line L is parallel to M, but you have another line like this. Suppose line P. This line is not parallel to L. So we should not bother about whether P is related to L, because L is not related to P. Therefore, P is not related to L. So we should not bother about these two lines. We bother about these two lines. We worried about these two lines. If L is parallel to M, then M must be parallel to N. That is true. Therefore, this relation is symmetric. This is true for whatever. Whenever two lines are parallel, then L is parallel to M, then M is also parallel to M. Right, fine. So this is symmetric. but not, and it is also reflexive. So, is this relation reflexive? Second relation?
No.
No, sir.
No, sir.
Not reflexive.
No, sir.
Right? So,
Symmetric.
it is not reflexive, right? Why not reflexive?
Because
Because
L1 is not parallel.
Because it's
Ah.
not
every
essential.
line
Line
is
if line is perpendicular to another line.
So if L1 is perpendicular to L2, then every line is not given, any line L is not perpendicular to itself, right? If this is my line L, then it is not L is not related with L. Any line, you choose any line, it is not related to itself. If you choose any line, then L perpendicular to L is not possible. Right, so L is perpendicular to itself is not possible. That means L is related to L is not possible with respect to second relation. Right, that means L comma L is not in R2 and therefore not reflexive. Right, so you give all the detailed reasoning so that your concept will be very clear. Now, is it symmetric?
Yes, sir.
Yes, sir.
So if
Yes, sir.
Yes, sir.
suppose some line is
Sir.
related with some another line M, right? That means L is perpendicular to M. But if some line is perpendicular to another line M, then M is perpendicular to L, right? That means M is perpendicular to L, and therefore M is related to L with respect to this relation, and therefore M comma L pair is in R2, right? So if L comma M is in R2, that means L is related to M, then we get that M is also related to M, therefore symmetric. So therefore this relation is symmetric but not reflexive. Fine. Now let me tell you one more example. Suppose X is set of students in A division. Right, so two students, X is related to Y if X and Y have interest in mathematics. So two students are related if they have interest in mathematics. Right. So is this relation, if two students are interested in mathematics, then they are related. If X is interested in mathematics and Y is not interested in mathematics, then X is not related to Y. Correct? Right?
Yes, sir.
Now, is this relation reflexive?
Yes.
Yes, sir.
Yes. Yes. Yes.
Yes, sir.
Yes,
Yes.
sir.
Because
Yes, sir.
okay, again you think about it. Is it reflexive? I am doubtful. Is it clear? Suppose I choose one student whose roll number is 10, but he is not interested in mathematics. It may happen. Do you realize this?
Yes, yes.
So suppose roll
Even
number
if
What, sir?
roll number 10 do not have interest in mathematics. Right? Suppose I take X is my X1, X2. These are my students. And suppose roll number 10, X10, do not have interest in mathematics, and therefore you cannot say that X10 is related with X10. When X10 is related to X10, that means X10 has interest in
interest in mathematics.
X10 has interest, X10 and X10 has interest in mathematics. But if X10 itself do not have interest in mathematics, right,
Yes.
has interest in maths, right? But this is not possible, right? Some student may not have interest in mathematics. So It depends on the students, right? And therefore here this relation is some kind of ambiguity is there, but you can just to understand you can have such type of examples, but it depends on what are the students. It may happen that it is not reflexive. It depends on the students, right? In some sense there is ambiguity in this kind of relation, so but for understanding you can think about it. Is it symmetric?
Yes, sir.
Symmetric
Yes,
is
sir.
clear. Symmetric is clear, right? Because if
Yes.
X and Y have interest in mathematics, then Y and X have interest in mathematics. So this is clear. Symmetry is clear. Right. Fine. So let my set X is equal to set of natural numbers. So this is my set of natural numbers. Now you know what is a set of natural numbers. 1, 2, 3 and so on. These are all natural numbers. Fine. Now define R on N. S. So now I am going to define a relation on this set. E for xy belongs to, or let me use some notation, M and N belongs to N. M is related to N with respect to this relation if and only if M divides N. Okay, let me, M divides N. So if M divides N, then I will say that these two elements are related. Oh, so fine. For example, 1 divides 2. 1 divides 2, therefore 1 is related to 2. Correct? Am I right?
Yes, sir.
Yes, sir.
Or 2 divides 10, therefore 2 is related to 10. That means pair 2 comma 10 is in R, or pair 1 comma 2 is in R. For example, is pair 3 comma 6 in R, relation R? Is it true?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, right?
Yes.
This is true. Now is pair 6 comma 3 is in R?
No, sir.
No, sir.
No.
No, because
No,
6,
sir.
6
No,
does not
sir.
divide 3. 6 does not divide 3. So therefore 3 comma 6 is in R, but 6 comma 3 is not in R. Right? So is pair 5 comma 7 in R?
No, sir.
No, sir.
No,
No,
Not
sir.
sir.
And therefore we
no,
should
sir.
not. So 5 comma 7 is not in R, so we should not bother about 7 comma 5. We are not bothering about such pairs. We are bothering about if some pair is there, then change the positions, then also that must be there. So therefore, is this relation reflexive? Is R reflexive? Is R reflexive?
No, sir. No, not
No.
reflective.
Is R symmetric? Is
Yes,
R
sir.
symmetric?
It is
Is it?
reflexive.
It is
But it
reflexive.
is
R is
reflective.
It
reflexive,
is
So
reflexive,
but
but
every
not
not
symmetric.
symmetric.
Not
so
symmetric.
every number.
Symmetric, but
R
reflexive.
is reflective but not symmetric.
Very good. Every natural number divides itself, right? Therefore, for you choose any natural number for n belongs to n, n divides n, right? Because if I take 5, 5 divides 5 because 5 is equal to 1 times 5. 7 divides 7, 100 divides 100. So you choose any natural number, that natural number divides itself. So for n belongs to n, n divides n. Therefore, for n belongs to n, n is related to n. That means the pair n comma n is in R This is true for every n in natural numbers. Therefore, for every element of n, it is related to itself with respect to this particular relation, right? So therefore, this relation is reflexive, right? Now, is it symmetric?
No, sir.
Right. So
No,
if
sir.
No, sir.
so,
No, sir.
so note that to prove that relation R is not reflexive, we need to produce an evidence such that what type of evidence we need to produce?
Sir,
AB.
is not symmetric or reflexive? Because it is
So,
reflexive, it
Yes.
should be symmetric.
Yes. Yes, sir.
okay. So, we want to relation is not symmetric. Then what we need to produce? We need to, if you want to prove that relation R is not symmetric, then we need to produce an evidence such that AB belongs to R, but BA does not in R. If you produce one evidence, कि AB is there but BA is not there, that is sufficient to say that the relation is not symmetric. Right? One evidence is sufficient. Right? One evidence. An evidence is sufficient to prove that it is not symmetric. So in this particular case, what is an evidence? There are many evidences you can produce. Right? And what is that particular evidence?
10 and 10 2.
So
10 and
3,
6, 6 is in R, but 6, 3 is not in.
Is not in R.
Right. So you have many evidences. For example, 5, 15 is in R, but 15, 5 is not in R. So many evidences are there. So one evidence is sufficient to say that it is not reflexive, and therefore this relation is not
Not
symmetric.
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 So this relation is not symmetric. So it is reflexive but not symmetric. So fine. Now definition of symmetric relation is clear.
Yes, sir.
Right.
Yes,
Very
sir.
good.
Yes.
So we'll go to the third type of relation. So we learned two types. So let me call this as second type, right? And our first type is reflexive. So first type is reflexive, second type is symmetric, and third type is transitive relation. So let non-empty. Please keep your mic off. A relation R on A is said to be transitive if, when relation is transitive, if whenever if for x, y, z in A, whenever x is related to y and y is related to z, imply that x is related to z. That is, please keep your mic off. Somebody has kept mic on, so it is disturbing. Please do not forget to keep your mic off. So that is whenever the relation R is transitive, if x, y belongs to R, x, y, y, z is in R, implies x, z is in R. So whenever x is related to y and y is related to z, then we should bother about whether x, z is in R. If x is related to y and y is not related to z, then we should not bother about whether x is related to z. Right. So, for example, okay, we can use previous examples, previous problem, or let me write down it again so there will not be confusion. So A is equal to A, B, C. I will take R1, AB, BA. R2 is AA, BB, AB, BA. R3 AA, AB, BA. R4 AB, BC, AC. R5 AB, BC, AB, BC, EA. R6 AB, BC, BA, AC. Okay, now check one by one which is transitive. You can think about reflexivity and symmetry, but we are interested in transitivity. So is transitive?
No, sir.
No,
No,
sir.
sir.
R4.
Transitive.
No,
Is it transitive?
no,
No, sir.
Why
no,
not?
sir.
No, sir.
Yes, sir.
Why
Because
not
C,
transitive?
B, because
Why
A
not?
is not belong. Sir, A is related to B and B is related to A, so A is not related to A.
A is related to B and B is related to A, but A is not related to A, right? But A is not related to A, right? By transitivity, what we expect, if A is related to B and B is related to A, then A should be related to A. So this fell, right? So not transitive. See, please immediately keep your mic off, because if you keep it on, then there are disturbances. So immediately once your what you want to say is over, then immediately you should keep mic off. Fine. So do you understand why this relation is not transitive? Is it clear?
Yes.
Yes,
Right.
sir.
Yes,
Because
sir.
A is related to B.
Yes,
Right. B is also related to A, but by transitivity we expect that A should be related to A. That is not there. Here A comma A is not there. So this is not transitive. So pair A comma A is not in R1. So not transitive. Okay, what about this second? You check.
Transitive.
It's transitive, sir.
Transitive.
Yes, sir. It is transitive.
So A is related to A, B related to B. So A is related to B and B is related to A, right? So B is related to A is related to B. Okay, you check all the possibilities. You need to check all the possibilities. So A is related to B with respect to this relation. B is related to A, and ultimately pair A comma A is also there with respect to this relation. This is there. So for this pair it is fine. Now B is related to A, B is related to A, and A is related to B. Then we expect that key pair B comma B should be there, and it is there. Right. Now you can check all the possibilities. So B related to what is one more possibility you need to check? B related to B and B related to A. Then we expect that pair BA should be there, which is there. Correct? Am I right? What we check further?
Yes, sir.
A related to A
Yes, sir.
and A related to B, then we expect that pair AB is there, and which is there. So all possibilities you need to check, and if it fails for at least one choice, then it is not transitive. So therefore it is transitive. So S relation is transitive. Fine. Now check for next.
No, sir.
It's not transitive.
Why not transitive?
Yes, sir, it is transitive.
It is transitive.
Transitive. Sir, it is.
Okay.
Yes, sir.
Yes, sir.
Sir, is it
Transitive.
transitive?
No,
B is
sir, it
related.
is not.
No,
Wait,
sir.
wait. B is
It's
related
not.
to B is related to A. Now A is related to A. Is this true? B related to A and A related to A. Is this true?
Yes.
Now we expect that ki B is related to A. We expect that B is related to A. That means, does this imply, does B related to A, is it true? That means pair BA is there.
Yes, sir.
Yes.
Yes.
Pair
Yes,
BA is
sir.
there. Yes. Okay, fine. Now A related to B and B is related to A. A related
Implies that
to
it
B.
to
Then
A.
we expect that pair A comma A is there. It is there, right? So therefore, all the possibilities you can check, and then it is transitive. Fine. What about R4?
Excuse me, sir.
Yes.
Sir, if B is related to A and A is related to B, then B comma B is not there in R3.
Exactly. So
Yes, sir.
very good. What is your name? Who told this?
Sir, Rishi.
Okay. What Rishi told, all of you understood? Ki
No.
B is related to A is there. That is fine. And A is related to B. That is also there because B is related to A related to B. Now for transitivity, we expect that ki B should be related to B. We expect this, but that is not happening here. Right? So this fails now.
Sir, I have a question.
Yes.
Sir, if A is related to A and A is related to B, so A should be related to B. So we are not having a bracket which is A comma B. Is it okay if we write it B comma A?
No. We cannot impose. We cannot insert forcefully. It is there or not, because relation already defined. Right now we are
Yes,
just.
sir. Then we also don't have a bracket. See, if in R3, A comma A and A comma B. So A is related to A is related to B. So A should be related to B. But we have a bracket which says B is related to A, not A is related to B.
See,
A comma B.
you have confusion. Ki A comma A is there, right? And A comma
Yes,
B is
sir.
there. And what we expect ki A comma B should be there, which is there,
Yes.
right? A is related to A and A is related to B. We expect that A comma B should be there, but it is there. So that condition doesn't, the transitivity doesn't fail for this pair. The transitivity fails for which pair? Transitivity fails for which pair? B is related to A
B comma B.
and A is related to B. For transitivity, we expect that B comma B pair should be there, but which is not there. in R3. Right, B comma A, because as far as set notation is concerned, we don't, it is not, doesn't matter ki which element is at which place. So BA, AB doesn't matter. We have 3 elements in R3 and position doesn't matter, right? Therefore, B is related to A with respect to R3 and A is related to B with respect to R3. So for transitivity, we expect that ki B should be related to B. That we expect, but that is not happening. Is it clear now?
So, sir,
Yes, sir.
it will
Thank
not be
you.
transitive.
Yeah, so this is not transitive. So A, pair A and B are in R3, but pair B comma B is not in R3. Therefore, R3 not transitive. Correct. So is it clear now? Is it
Yes,
clear?
sir.
So
Yes, sir.
you should check all the possibilities. No possibility should be missed out. Then only you can declare if for every choice of this pairs, it should satisfy the condition for transitivity, then it is transitive, otherwise not transitive. Right, so you just think about it. What about R4?
It is
Not
transitive.
transitive.
Is
Transitive.
Yes,
Transitive.
sir.
Not transitive.
Transitive.
No.
Not transitive, sir.
Not
Not
transitive.
transitive.
Yes, sir, not transitive.
BB is not there.
It is
Not
transitive. Transitive.
How?
okay, wait. First of all, you check all the possibilities, right? So don't be in hurry. So just think over it and check all the possibilities. Ki A related to B, B related to C, and what we expect, A related to C should be there, which is there. A related to C is there, so no problem. For this pair, it is okay. Now check for another pairs. Now B related to okay, check for another pair. So you choose any two pairs. First I took these two pairs. Now A related to B, so I cannot take this one first and third because that is not the appropriate pair. So B related to C, so this is not a appropriate pair. So okay, is there any pair which violates the rule of transitivity?
Yes, sir.
No, sir.
If
B,
A,
rela-
A
B
No,
related
related
no,
to
to
sir.
B
C,
and
A
B
related to
related
B,
to
and B
A.
not related to B.
B related to
C,
B related to C,
A related to B,
A related to B,
then B not related to B. There is not pair of B and B.
ah, so A related to, let me write down in proper order. A related to B, B related to what?
Not, sir. B related to C,
B related to C is there.
A related to
It
B.
No,
is
that
not.
is no. This you are
But
you
we
have confused,
cannot write like this, na?
right? So A related to B, whether B related to somebody else, then we are bothering about that. If A related to C and is C related to something, then we bother about B related to that thing, right? So if so B related to C and is C related to something else, then we bother about whether it be related to that, whatever it. Is it clear?
Yes, sir.
So question is, does there exist a situation? Does there exist? Does does
Sir,
yes.
sir, if B is related to C and A is related to B, then B related to B doesn't exist. So it is not transitive.
Tell me once again what you said.
B related to C,
B related to C and
A related to B, A related to B,
uh, then
then B related to B is not there.
why we want B related to B? Because B related to C and C related to something else. Then we bother about that. This is not the appropriate choice.
Sir, can you please repeat?
Okay, does there exist? Let me tell you once again. Does there exist a situation? Please keep your mic off. You turn on your mic whenever you want to talk, right? So, does there exist a situation such that X related to Y, Y related to Z, but does not imply X related to Z? Does there exist such situation? You give me the situation key, this member and this member are same. Then we expect that key these members are related. Right? Do you understand? The second member of first pair and the first member of second pair are same, then we expect that the first member of first pair is related to second member of second pair. Do you understand?
Yes, sir.
Can
And sir, the first two pairs are in set. Then we compare the third set.
yes, if you have
Otherwise,
otherwise don't bother. Otherwise don't bother
yes,
about the pairs, right? So
yes,
what you said, what somebody said ki B related to C and A related to B and B is not related. So that is not the appropriate choice because B is related to C. Then we want pair where C is related to somebody else. Then we bother about whether B is related to this. Right? This is not the appropriate choice. AB is not appropriate choice. Right? If B related to C, the second component of first pair, same as first component of second pair. If such pairs are there, then we bother about B related to this, whatever is this. Is it clear? Is it clear?
Yes,
yes,
sir.
sir.
And
Yes,
therefore,
sir.
so there is no such evidence. What type of evidence? There is no such evidence for which the such situation arises. Therefore, this is transitive. R4 is transitive. Right? Because you cannot produce a pair like this, X related to Y and Y related to Z, but X is not related to Z. You cannot give me such evidence, so that you have to accept that the relation is transitive. Right? So for transitivity, so note this, or we need we need to produce an evidence such that xy and yz are in R, but xz not in R. Right? For not transitive, or not transitive, for not transitive, we need to produce an evidence such that xy belongs to R and yz is also in R, but xz is not in R. Such evidence we want to produce. Right? So xz is not in R. Such evidence we want to produce. So fine. Is it clear now?
Yes, sir.
Right. So
Yes, sir.
which pair we expect if we have two pairs? The second component of one pair is same as first component of second pair. If we have such pair, then we expect that the pair xz should be there. That we expect. If it fails for if we produce such kind of evidence, then relation is not transitive. And if there is no such evidence, then we have to accept. Right. So this is a logical fact, and you need to understand what is a logically. You can produce evidence, then you say that this is wrong. Right? So some person is a guilty. How will you prove that some person is a guilty? That means you have to produce an evidence. One evidence is sufficient, right? Do you understand? One evidence is sufficient.
Yes, sir.
Exactly same philosophy. If you cannot produce an evidence against that person, right, then you have to accept that he is not guilty. He is a right person. He is a good person. Right. So to prove that some person is not a good person or not is a guilty, then one evidence is sufficient. Right. So to prove that some relation is not transitive, you have to produce one evidence. To prove that some relation is not symmetric, then also you need to produce one evidence. Right. So you have to produce one evidence. The pair AB is in R, but BA is not in R. That is not symmetric. Fine. So now the concept of transitivity is clear.
Yes, sir.
Okay,
Yes,
now
sir.
go back to our the previous example, the set of all lines in the plane. What is my first relation? Two lines are related if and only.
Excuse me, sir.
Yes.
Sir, will an empty relation be transitive or and symmetric?
Yes. Very good question. Let A be a non-empty set and R is empty set. Is R reflexive, symmetric, transitive? Okay. Now logical. This is a very logical and philosophical question. Okay. When I will ask questions, sub questions. So Q1. When you say that R is not reflexive, when you say that R is not reflexive, if I can produce an evidence, when I produce an evidence that there exists X in set A such that X is not related to X or pair X comma X is not in R, then I can say that if one pair is sufficient, you can see in our previous examples. So this relation R2 is not reflexive because why R2 is not reflexive in this?
Because CC is not belong to.
Exactly. The one evidence is there. C comma C is not in R2. One evidence. A comma is there, B comma is there. That is not an issue. But C comma C is not there. That is the point. So one evidence. So can you produce an evidence that X comma X is not in relation? Okay. Now can you say that this relation, empty relation, is not reflexive? Can you give me any evidence?
No, no evidence is there.
So you cannot give me evidence. So you have to accept now it is reflexive.
Yes.
Right? If say the same
Sir,
example.
but A is not empty set. Na?
No. Can you give me evidence?
Yes,
Sir,
sir.
if we
Sir, if okay, say.
Right? Give me evidence
Sir,
that pair. Oh.
sir,
Sorry.
if
Sorry.
A is
For example, if my set is A, B, C, and this is empty, so empty set is not reflexive, right? I'm sorry. So pair A comma A is not in empty set, right? Or pair B comma B is not in empty set, or C comma C. So the empty relation is not reflexive, right? So uh, empty set is not reflexive, right? Fine, because we expect that there is evidence, but there is nothing. So therefore, A is not related to A, B is not related to B. So the pairs for reflexivity, all the pairs should be there: A comma A, B comma B, C comma C. So therefore, this relation is not reflexive. Very good, fine. Why? Because A comma A, if I am talking about this problem, particular set ABC, right? So not reflexive. So it depends on what is your set. Is it clear now? Is it clear now?
yes.
Fine.
yes, sir.
Yes, sir.
So when you say that R is not symmetric, when you say that R is not symmetric? And second question. If you can produce, if there exists AB in R but BA not in R, correct? This is answer. When we declare that relation is not symmetric, if you can produce evidence, AB is in R but BA is not in R. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Now you give me pair AB such that BA is not in R. Can you give me pair in phi?
No,
No,
there
sir.
is
No,
no
sir.
No, sir.
So there is no
element.
evidence. There is no evidence at all. So by vacuously it is true. So phi is symmetric. Right? Because if you can produce, if you can give me pair evidence, then I will say that it is not symmetric. But you cannot give me evidence, such evidence. AB is in R but BA is not in R. So you have to accept it is symmetric. Right? Is it clear now?
Yes, sir.
Yes, sir.
When you say that R is not transitive, when you say that R is not transitive, so there exists AB, BC in R, but AC is not in R, right? So if you can prove evidence,
That is
right? If you can produce evidence A is related to B and B is related to C, but B is not related to such evidence is there, then it is not transitive. Now, can you produce the such evidence in empty relation?
No, sir.
No, sir.
Because you cannot give me such pairs so that check whether AC is in there. So you cannot give me any pair, so you have to accept it. So phi is transitive, right? So therefore empty relation is not reflexive, but it is symmetric and transitive. So that is clear. Very good. So we'll stop here and
Sir,
Sir,
yes.
but in
sir,
the starting only of every relation we have